Hello, welcome to another video as part of the video series on current electricity. In this video, we are going to look at some work examples. Here in example 1 that we have, we are given a circuit that has two resistors in parallel and one resistor in series, and it's connected to a voltage source of 24 volts and with internal resistance of 3 ohms. So you have to determine the value of the current I that is flowing through the circuit and the current through the 4 ohm resistor, and the voltage across the 3 ohm resistor. Okay, so how do we solve that? First, to determine the current, we know that we need to determine the total resistance that is flowing, the total resistance in the circuit. So the current is the EMF of the cell divided by the total resistance connected to the circuit plus the internal resistance of the cell. So we looked at this formula in previous video. Now, how do we determine the total resistance? Now, we need to first determine the resistance for the parallel connection. Then we add that to the series one. Now, for the parallel connection, the total resistance will be, using the shortcut formula I gave previously, RT will be product of the resistances, R1, R2, divided by the sum of the resistances. So if you use that product over sum, the product of these two, if this is R1 and this is R2, and this is R3, for example. So if you multiply those two, 6 times 4 divided by 6 plus 4, so that will give you 24 divided by 10, which is 2.4 ohms. So this will give you 2.4 ohms. So that means that circuit can be reduced to, so the resistance, let me do it this way, the resistance arm can be reduced to this. You have the 3 ohm here, and you have this parallel resistor. Let me call it RP. Make life easy. RP is for the parallel part. So you have the RP here. So, and we've gotten the RP as 2.4. Now this will then be reduced to this, the RT. And RT will be 3 plus 2.4 because they're in series. And that will give you 5.4 ohms. So this is 5.4 ohms. So the single resistor that represents all these resistances will be 5.4 ohms. Okay? So, and that is the resistance that we need here. The current will there be E, which is the EMF of the cell, 24, divided by the total resistance, the total external resistance connected, which is 5.4, plus the internal resistance of the cell, 3. And that will give us 24 divided by 8.4, and that will be E equal to 4 divided by 8.4, 2.86 amps. So that's the current and flowing through the circuit. Okay, so that's the first part of the question. The second part says calculate the current through the 4 ohm resistor. So to get the current through the 4 ohm resistor, we can use the current divider rule. We can do it here. So we can use the current divider rule. So if I call this the current that will flow through this I1 and this current I2, because we know the current that will flow through this 3 ohm is I. So it's connected in series to the battery. So that these two currents will recombine here and they will form I again, and that will keep going around the circuit. So if I use current divider rule, the current that will flow through the 4 ohm resistor, I2, will be equal to R1 over R1 plus R2, called the formula for current divider rule, multiplied by the current they are sharing, which is I. And that will be equal to R1, which is 6 over 6 plus 4 multiplied by 2.86. So that will give us 6/10 multiplied by 6.8, 2.86, 2.86 multiplied by 6 divided by 10. That was 1.716. And so that's the current flowing through the 4 ohm resistor R2 here. So the voltage across the 3 ohm resistor, that's easy because I know that the current that is flowing through it, and I know the value of the resistance. So the voltage across the 3 ohm resistor, voltage across the 3 ohm resistor over the current through the 3 ohm resistor multiplied by the resistance, the 3 ohm resistor itself. Now, what is the current? It is 2.86. That's the total current. 2.86 multiplied by 3. So 3 ohm should be 2.86 multiplied by 3. 2.86 times 3. And that will give you 8.49 volts. That's the voltage through the 3 ohm resistor. Okay. I think that's it for question 1. So let's look at the second question that we have. Now, you have to consider the circuit below. You have these circuits, 2 resistors in parallel, and you have another 2 resistors in parallel. So you have to determine the ammeter reading. That's the current that will flow through the entire circuit. So what we can do first is to reduce this entire resistors into a single resistor, which is the total resistance. So these 4 ohm resistors in parallel will give us let's say I call that RP1 parallel 1. That will give me product over sum. That's product divided by the sum of the resistances. We recall the formula that we used earlier. So that will be 16 divided by 8, which is 2 ohms. For this parallel, the second parallel connection, RP2, so that will give you the product of the resistances divided by the sum of the resistances. So that will be 36 divided by 12, and that will be 3 ohms. Now I've reduced the resistances into 2 in series because the total resistance here for this parallel connection will be in series with the total resistance here. So I'll have something that looks like this. Let me just show it. Here, I'll have something that looks like this. That and that. So here, this is 2 ohms and this is 3 ohms. Okay. So therefore, the total resistance will be 2 ohms plus 3 ohms. Sorry. So the total resistance RT will be R for the parallel part 1 and R for the parallel part 2, and that will be 2 plus 3. Okay, so 2 plus 3, which is 5 ohms. So that's the total resistance. Then I can determine the current now because I know the total resistance and I know the EMF, the voltage. So this battery does not have internal resistance in this case. So it's going to be I will be the voltage, which is the EMF in this case, divided by the total resistance. There is no internal resistance. So I will be, or the voltage 12 divided by 5. So 12 divided by 5, that's 2.4 amps. So that's the ammeter reading. Okay. Then the next question is the current through one of the 4 ohm resistor. So we know we've gotten the current that flows here from here as 2.4 amps, which is the total current I. So let me just bring that as I. So the I will divide when it gets here, and the I will also divide when it gets here. So to get the current through one of the 4 ohm resistor, if I call that current this one I1, I call this one I2, the one that flows through here. and I call this one, the one that flows through this one, as I3, and I call the one that flows through here I4. So the I2, which is the current through the I1 will be equal to I2 in this case because the resistors are the same. So how do I get that? If I use the current divider rule, I know that I1 will be equal to R2 over R1 plus R2 multiplied by I. Okay, so I1 will be equal to 4 divided by 4 plus 4 times 2.4. The total current. So I1 will be 4 over 8 multiplied by 2.4, and that will be this half, then stack that by half, that will be 1.2 amps. So, and that makes sense because you just share them equally. The 2.4 will be shared equally between the two 4 ohm resistors. Okay, so the 1.2 that will flow through this will combine with the 1.2 that will flow through this 4 ohm resistor here, and they will make the 2.4 here again. So if this is 2.4 amps, this will also be 2.4 here. So that same 2.4 will divide here, based on the resistance here. So you have to find the PD across the 6 ohm resistor because they're in parallel. We know that the PD across this will be the same as the PD across this. Okay, so how do I get that potential difference? I know that the PD across this 6 ohm resistor, V, let's say V6 ohm, will be current through the 6 ohm multiplied by the resistance of the 6 ohm. Now, how do I get the current? I can use the current divider rule to get I3. So using current divider rule again to get I3, using current divider rule. So I3 will be, this time if I call this R3 and I call this R4, it's going to be R4 over R3 plus R4 multiplied by I. And that will be 6 over 6 plus 6 multiplied by 2.4. And that will be, so 6 over 12 times 2.4. We share it equally again, so that will be 1.2 amps. So the same 1.2 will flow through each of amps. Now, therefore, the voltage across the 6 ohm resistor, V 6 ohm, should be I3 multiplied by, should be, I3 multiplied by R3, which is the 6 ohm itself. So V of the 6 ohm will be 1.2 multiplied by, what is R3? 6. So that will give you 1.2 times 6, which is 7.2 volts. Okay, so that's the voltage across the 6 ohm resistor. So there's another way you can actually do this. There's another way you can calculate this, this current, I1. So if you want to calculate this I1, you can first determine the PD across this arm, this end. If I call this V1, because it's going to be the same for these two, and I call this V2, then I can, if I use voltage divider, I can determine, if I can combine these two resistances, remember I combine them here, so I can get the voltage V1. So V1 will be the resistance, this combination, 2 divided by the total resistances, which is 5, multiplied by what they are sharing, 12. Let's see, what would that give? 24 over 5. So what's 24 over 5? 4.8. So 4.8. So that's this V1. 4.8 volts. So what is V2? It's easy, you just subtract 12 minus 4.8, 7.2. That's exactly what we got. That's exactly what we got here for the voltage, 7.2. Can you see it makes sense? So that's, if you want to get that voltage, then you can use this 4.8 volts to get the current I1, because I1 will be that voltage across the resistor, 4.8 divided by the value of the resistor, 4. So I will be 1.2 amps. So which is what we got. Okay. So whichever method you want, you use. So that's it for the video, and I will see you in the next video. Bye-bye.